Well, here's an overall layout of the second generation PLC project, as the track layout hasn't changed much except for over here where this used to be a spur track. I've now added a fourth switch to turn this spur track into a team track. Having the additional inputs and outputs on the PLC allowed me to do it. And this here would be the main terminal interface to all the various block detections and sensors, just to try to cut down on how messy the wiring is leading up to the PLC controls. And this overall here is the PLC controls. It's been upgraded with a MicroLogix 1400 and additional input and output modules. Power supply. This here is the automatic and manual circuit, which is basically a start-stop circuit. And with the old system, I wasn't able to utilize this. This is a solid-state interface board that's been modified so that I could actually now read the switch positions. Right now, all four LEDs are green, which indicates all four switches are thrown to the throughway. And this here is an Omron solid-state relay block, which handles all the block detection. This electrically isolates the inputs from the PLC to the track. This is in the event of a derailment. If track power were to feed back into, it could damage the PLC input. This way, worst case, one of these would blow out, and then I would just simply pull it out and replace it. And as in with the first generation, I've integrated a PNOS safety relay, mainly just to follow practices of building controls. It will cut off the track power and 24-volt power if an emergency stop is pressed. And these orange relays here are now the track power. There's now 6 track power controls on the layout instead of 4 with the old layout. These slim relays control the switches. The very first one actually enables the switches to be thrown. That's because these are single pole double throw relays, and so one side is always connected. So if you go over and look at, which would basically be the automatic throwing of these switches. So you don't want this to be constantly engaged, because if the switch, like as you see here, it isn't doing anything because the switch is latched into position because the LED is green. However, if the switch is jammed, the motor in the switch will keep trying to drive that switch and would burn out. So to prevent that in automatic mode, the very first relay actually disconnects the connections. So if the switch jams, it would only be enabled for a half a second, and it would prevent a motor burnout. And then over here is the modified CW80, which has the automatic relay. And these 3 relays will take the place of the direction, whistle, and bell buttons, so that I can remotely control the direction, whistle, and bell. And this little black box is the analog interface, which eventually, the plan is the PLC would actually be able to control the throttle output in automatic mode, and it will also have a sense of the actual track power in case, say, the transformer shuts down due to a derailment. And the engineer control panel was modified first to accommodate for the extra track powers and for 4 switches instead of 3. So basically, the first relay, this one handles automatic and manual control of the reduced power section. Because my house isn't level, the certain tracks have a downgrade and an upgrade, so the voltage is reduced on the tracks that the train would be traveling on a downgrade to try to even it out, because this is purely a conventional layout. And eventually the PLC will be able to control that automatically, and that's what this relay does. But in the meantime, I could just override that. And then these 3 relays handle the automatic control of track power. And then these 4 relays, these hand off between manual and automatic control of the switches. These are actually force-guided relays so that they won't close or open if one of the contacts jams, and that's just for safety to prevent a motor burnout in the switches, as I described earlier. The HMI screen has been completely rewritten from scratch. As you can see, the new layout showing all the optical sensors, 8 of them total, the switch positions, which even in manual mode they will change, and when you see a green bar, that indicates that a train is occupying that block of track, which right now there's a train parked on the side track and the throughway west track. This will also tell me if the layout is an automatic or manual control. The function keys, now this will be the train operation routines where you'd be able to select different train operations, and I'll get to that in a little bit. CW80 control, which right now there isn't anything written into it, but that will be planned. And this here is, most importantly, diagnostic screens. As you remember from the first generation project, I used capacitors to try to smooth out the chatter as the train travels over, the wheels of the train travel over the track, which was causing the block detects the chatter. That's been completely eliminated, and I'm using a standard debounce timing circuit for the block detects and the optical sensors, because sometimes the optical sensors will see a gap between the cars, so I don't want it to react to it. I'll be showing this, but the red would be the raw input from the PLC and the green would be the debounce, so this way I could see how it's reacting and if need be to adjust the timing accordingly. Other diagnostic screens shows like whether I have an emergency stop, if the unit's an automatic or manual, if the 2 push buttons on the button panel are being activated, and the outputs for the soft hard alarm and the lights, and then also the CW80 control. Because I've been able to use that solid state interface board, it can now read whether the switches are glowing green or red, which indicates if the switch is to the throughway or the turnout. So as it's shown here, switch 2 is now thrown to the turnout. The third LED, or the third indicator light, is indicating if the switch is latched into position, which means either the throughway or the turnout is lit. If the switch jams, that light won't be on, and the PLC will know that the switch is not in position. And this is another diagnostic screen, which is for the track switches and the track power. As I shown earlier, the first relay enables the ground connections to the switch control, so that way in the event that a switch jams, there won't be a burnout, because like I said, these relays are single pole double throw, so there's always one contact always engaged. But as long as the enable switch isn't closed, it basically is open. It's an open circuit. And then here's a new alarm screen, which now has text alarms and is now capable of basically an unlimited number of alarms by using a recipe or a message database lookup. The button box hasn't really changed since the first generation. It has the emergency stop, which actually shows here, when you have an emergency stop situation. So this will reset the emergency stop. Stop button would put the unit in manual mode. Start button puts it in automatic mode. And I have available 2 input buttons. This button is not used because the pedestal won't have a third button, so it's just simply not wired up. When the unit's in automatic mode and track power is enabled through the PLC, the bars will turn white, indicating that track power has been energized on that section of track by the automatic mode. In manual mode, of course, that doesn't do anything. Now, I'm not sure really how hard or easy this is going to be seen, taking a video of the screen, but I decided to write all the support routines first before doing any train operations. Of course, I have the main program, which is the main ladder. In here is the debounce routine, which takes the place of the capacitors, and this is what eliminates the chatter on the block detects and on the optical sensors by simply using a series of timers that will prevent the chatter. Here with the train running in manual mode, you can see the debounce anti-chatter routine working. As I said, the red indicators are the raw PLC input, and the green indicators when the debounce program takes over. So this way it provides a smooth on and off transition of the block detects and the optical sensors. This is just running the train around the main line in manual mode, but you can see how the debounce circuit works, and that you can see an enormous amount of chatter on especially on the block detects. And that's just because of dirt on the track, the wheels, and just that the train can't maintain 100% contact, due to dirt and grime. So this eliminates that problem. So that's this debounce routine. This routine handles the track power, taking a different approach by using integers. It basically is if a certain integer is not 0, it energizes that section of track. This routine is when the unit is put in automatic mode. It will run once, and right now it doesn't really do much of anything other than just say it's complete. But down the road, if I need it for something, it's available. This routine handles throwing of the remote switches, all 4 of them, which also accounts for the fact that it checks the switches and the optical sensors to make sure a train isn't blocking the area of the switch, so that would cause a jam. And it also verifies that the switch is now latched into position once they're changed. This handles the analog capabilities of the PLC, which right now is empty. That's going to be future expansion. This routine reads the switch positions and stores them in what I've shown you in the diagnostic screen. It simply reads the handling board and puts the values in those variables, so it knows where the switches are. This routine will just simply detect movement along the main line just to make sure a train hasn't stalled or derailed. This routine is a rewrite from the first generation, which handles forward reverse movements off the side track and the throughway, with these areas of track being the throughway, which this is now called the throughway west, and the other train is on the side track. And then it also here for the throughway east and the team track, by utilizing the optical sensors, as I described in the first generation project. Lionel trains have the capability of moving forward and reverse, but some of the trains, if the track power is off for more than, say, 20 seconds, the next time track power is applied, the train will move forward. Other locomotives, particularly these RS3 units, will maintain its forward reverse sequence no matter how long the track power is off. And as I described in the first generation project, the sequence goes forward, then neutral, then reverse, then neutral again, and then back to forward. So it's impossible for the PLC to know what the next sequence of forward and reverse that the train will operate in, because, like I said, some of them change. So this routine, when I want to move a train from either of these tracks, it will just watch the sensors and toggle the track power accordingly to get the desired direction. And the next routine I have here is manual. When the unit is put in manual mode, this routine will run, which can be used basically mainly as like a cleanup routine for the PLC if needed. And this routine, this was a routine that I never got working properly with the first generation project called Park. That was also due to programming practices that weren't the best, but with some research and some questions online, I've resolved those issues and programming in a better form to prevent it. As described in the first generation project, when a train is brought into a section of track, when the track power is dropped, some locomotives will tend to coast after, for a distance. Others will stop pretty much immediately. So there's always the possibility with a locomotive that coasts that it may travel too far and block the next optical sensor or come in range of the switch. So this routine is designed to detect that, and if necessary, will toggle the track power to back the locomotive up so that it's in between the optical sensors, not blocking the switch, and in the block of track that it's supposed to be in. This routine is a new one. It's called Main Sense. This not only will sense a train on the main line, but would also sense if it's moving, stopped, or what direction it's traveling. This can be useful for if I need to change the direction of the mainline train for certain train operations. This routine is available for use. And the rest of these ladders, which right now most of them are blank, they're pretty much all blank. These are the various train operation routines that can be selected from the HMI panel. Routine 0 would be invoked when a routine has come to an end that is not endless and there's no routine next to run. So this routine would run, which could either clean up or stop the train, which right now the program is not designed to jump to this at all. It's just there for a future possibility. Now, as a demonstration, I wrote a simulation for routines 1 through 4 to test out the routine selection. They're just simply just a bunch of timers, and what it's designed to do is the first 2 routines are endless running routines. Say, for example, in the first generation, the last program that I wrote was the main and side interchange, where the one train that would run the main line for, say, 5 laps, and then it would stop, and then switches would be thrown to the side track, and then that train would run the main line for, say, 5 laps, and then it would just keep endlessly switching which train would run. That would be considered an endless routine. Another type of routine would be just one that does a certain kind of operation and then ends. One example could be is if, say, I want to interchange, I want to actually swap the train, say, between the side track and the throughway track. That it would go through, and then basically once the trains are interchanged and it's settled on the side track, this routine would basically end. So what I did is I wrote simulations for routine 1 and 2 to be endless and routine 3 and 4 to not be endless. So right now the way to invoke a routine is you press it, and certain routines may have a screen to select, an option. So when that one is, it jumps to that screen, and then when I select what I want, which right now there's nothing there, this indicator will come on to say that I've selected the routine, but I haven't confirmed it, in case I accidentally press it by mistake, being that these are close together. So to actually make it, you press the confirm button, and now that routine will be running. And what I did for the simulation is that I just simply have it light up one of the button lights, either first steady on and then blinking, just to indicate that there's a routine running. And being the fact that this is an endless running routine, it will just continuously run until something else is selected. So say, for example, okay, I want to change train operations to this. As you'll see, routine 1 will still be running. Routine 2 is now being selected and then now being confirmed, and then what'll be confirmed when I press this button. So when I confirm it, you'll see that it's listed as the next routine to run, and this indicator will light up, which tells this endless routine that it wants to end, end request, so that when it's done with the cycle, that routine will now end, and then this will become the current running routine. As you see here, the end request indicator went out, and now routine 2 is running, which in this case, it just simply blinks the other light endlessly. So as a demonstration for a routine that will not run endlessly, we'll select routine 3. And I just want to give it a chance so that it starts on a cycle. And I'm going to confirm it. I have an end request for the endless running routine. And when that routine is completed its cycle, routine 3 now runs, which I have it just simply blinking both lights. The difference here is when this is completed, this routine is not endless. It will just simply default to having no routine running. So when that routine completes, there's no more routines running, and it's ready to select another routine. So I have up to 14 routines defined, and if need be, I add another page to decide, if I decide to really go crazy with adding more train operations, I have another page available for it. But as you can see, like I said, this routine would just be able to be selected and run, but I'm giving the option that if there's a routine that can be used, like I want to use this to stop the train, it will jump to this screen, and then I could say select where do I want to stop the train, whether it be either throughway or which part of the main line. Then I would just basically select that there and then go back to the routine and then tell it to confirm, and then that routine will run with the selection I said. Say, okay, I want to stop the mainline train, but I want to stop it on the throughway west. So that gives it the it jumps to that screen. Depending on what type of train operations I write, there may be other screens written in. Well, one thing I should note is there is an indicator here, which is dark, which would light up yellow when it's triggered. That is for the possible future expansion of having a routine 0 run when there's no routine. Like right now, you just saw routine 3 end. What the plan would be is routine 0 would run, and then when that would end, it would just basically go back to the screen, and that just would be an indicator to say routine 0 is running, and then that would go out. But for right now, that's not doing anything. I'm not 100% sure if I'm going to utilize that or not, but I just have it there as for a possible future expansion. Basically, I'm trying to write all the backbone programs for this train, so now I could just focus on writing just the train operations, putting them in their needed routines, and then I only have to troubleshoot that, and I no longer have to make any more test programs. So that's a basic tour of the Model Train PLC project, the second generation, with those all the controls.